Hey guys, welcome back. Now we're going to talk about literal equations and formulas. So let's write down a couple of formulas that you guys may have seen before, in any of your math and your science classes. One of those may be density. Do you remember maybe seeing that is a formula? I know you guys know the Pythagorean theorem. I'm just going to put Pythagorean theorem, which is a squared plus. I know you guys have seen that one before. There are a ton of area formulas. I'm just going to give you one. My favorite is the area of a triangle. A equals 1/2 base height. And then, of course, we have volume formula. 1. V equals length times width times height. So there are also a ton of volume formulas. I'm sure there are a ton more you can think of out there that we've used before. But those are just a couple that we discussed in class. So take a look at those formulas and tell me, what do you notice about all of them? Well, we notice that each formula has 2 or more variables. Look at that. For area, we have A, B, and H. For the volume, we have 4 of them there. Volume, length, width, and height. For density, there's 3. Density, mass, volume. So there are at least 2 or more variables in every single one of those formulas. You may hear the train in the background. Sorry about that. So, how are all with so far? Well, they don't have as many numbers. We have to put the values in for the variables. So they don't have numbers. We have to put values for variables. So they don't have the numbers as we do. We were working with things like 2x plus 5 equals 7. Well, the only variable we have is 1, and the rest of them are numbers, so we can easily solve for x. They don't have numbers, so we've got to put the values in for the variables. All right. So there's a little bit of vocab, so let's talk about it. A formula, you guys have heard of it. Don't think too hard about it. It's just an equation that states a relationship that should say relationship. See if I can pull it out a bit. There you go. Between, I'm going to put BTW for between, one quantity and or more other quantities. So while we let it catch up and let you guys write that down, think about what we have. Well, when we had density equals mass over volume, well, that's comparing density to mass and volume. That's 3 quantities. When we had the Pythagorean theorem, we have a squared, b squared, and c squared. That's 3 quantities. So it states a relationship between one quantity and one or more. Density and mass and volume. All right. A literal equation is an equation in which letters represent. So an equation in which letters represent both variables and known constants. So while you guys write that down, the formulas we wrote up there, D equals M over V. If we know M and we know V, well, we still write the formula D equals M over V and then plug in what we need to know, right? So a literal equation is a bunch of letters. And both the variable, the thing we don't know, and the things we do know, the constants that we can put in, are all represented by letters. Hint, one that's a big deal, a formula is a type of literal equation. So a formula is just a type of literal equation. It's just one of the things we can do with it. So you'll see there that there is a link to a virtual nerd video. You can go to that video and watch it if you'd like. I showed it to my kids in class, but I'm not going to show it in this little video that I'm making. Okay? So now let's do some literal equations. So it says Nora drew a non-square rectangle. She drew the length of each side from end to end to make a line segment to represent the perimeter. The big deal word here is perimeter. So when talking about the perimeter, we mean adding up all the sides, right? So look at A. A says write an equation that represents the perimeter. Well, let's do that. Well, we have multiple ones that we could do for that. But the one that my class came up with was P equals length plus width plus length plus width. Because we just went around it. Length, width, length, width. We add it all together. So there is an equation that represents the perimeter. B says we want to rearrange the order of the sides so that we can represent the perimeter with a different equation. And we asked if it's equivalent to the first. So in my class, we talked about writing it like this. If I wrote the perimeter instead with length plus width, is that the same as the first? Well, it is. They talked about why. Why is because there's still two L's and there's still two W's. So if I chose to write it as P equals W plus length, the same. Or what about P equals W plus L plus W plus L? All of that still the same. And my favorite, P equals 2 times L plus 2 times W. Not too bad, right? It's still the same thing, because remember, adding a bunch of things is the same thing as multiplying it by the number of things you have. So we have 2 L's added, so we took 2 L's. We have 2 W's added, so we took 2 W's. Alrighty, so all of these equations are equivalent. So they're all equivalent. All right, now the fun part. Ways that we can structure them in different ways. So we've done everything in terms of P, the perimeter. What if I wanted to make this in terms of L, where I know the width and I know the perimeter, but I need to know L? So let's do it. Take a look down here. I'm going to use this one, P equals 2L plus 2W. We know that means perimeter. But I kind of want L to be all by itself. So I'm going to highlight L. We want it all by itself. Well, what's bothering L? The 2W. So let's subtract 2W on each side. Well, that's still going to cancel, because even if we don't know what W is, 2W minus 2W is still 0. But can we make P minus 2W any simpler? No, we cannot. So we just keep it. P minus 2W equals, bring down what we still have, 2L. Well, our goal is still to get L all by itself. So L's not by itself, it's being bothered by that 2. But we know how to get rid of the 2. It's being multiplied, so we're gonna divide. That's gonna cancel, and we're gonna divide by 2 over here. Well, we can't do anything now, because we don't know what that number is. So L is equal to P minus 2W all over 2. There you go. Now our L is all by itself, and if we know the perimeter and the width, we can just plug it in to get what our length is. So another way, this equation right here is just as simple and the same type as that up there. We just moved it around. One of the ways my student said it that I really liked is we rearrange. We're just rearranging things to get the letter we want on one side and all the others on the other. So it's the same equation, just moved around. We can also do this with width. So width is equal to P minus 2L all over 2. We solve it the exact same way as we would with the W, or with the L. So these 2 are another way that we can write the perimeter formula. Alrighty, let's keep going. So first things first, our essential question is, how is rewriting literal equations useful when solving problems? Well, for my kids, I told them we'd come back at the end and talk about that. So that's what we're going to do. Look at our first example. Janet wants to calculate the time it takes to earn a certain amount of interest on a principal amount in an investment with simple interest. What equation can she use? So I don't know about you guys, but my kids did not know the simple interest formula. So let's talk about it. That simple interest formula is I equals P R T. That's the formula we use. I equals P R T. Every single one of those letters stands for something different. I stands for your interest. Or more like what you're going to get plus the interest that it has. So whatever you put in plus whatever interest. P stands for your principal amount. By principal amount, I mean, what did you put in the savings account to begin with? Your R is your interest rate. What interest are you earning? Interest rate. So if you were saying we're going to gain 2% every month, then that would be your R, your interest rate. And T, I bet you guys can guess. Time. How often are you earning interest? Is it every month, every week, every day? Probably not every day. But usually it's every month or every few months. So she wants to know time. So which variable is she interested in? She's interested in T. So what I'm going to do is I'm going to rewrite this guy. I equals P R T. And we're going to highlight T because that's the one we care about. Well, T is being bothered. We want all the other things. We're going to pretend like we know interest, principal, and rate. We want all the other things on the other side. We want T all by itself. So let's look at what's bothering T. Well, look at T. It's got a P and an R bothering it. If those are just numbers, what is it doing to it? Well, anytime anything is just right next to each other, we know they're multiplying. So we do the opposite of multiplication, which is division. So this and this will cancel. Can we simplify IPR? We cannot. So I over PR is equal to RT, which is now all by itself just like we wanted. So what does this mean? She now has an equation to help her with finding T. By plugging in I, P, and R. So she knows her interest, she knows her principal, and she knows her interest rate. She knows the amount she wants to earn, the principal, and the interest rate. She can just plug it in, and it'll give her time. All we did was rearrange. All right, again, I'm not going to do the show you're learning. You guys can try this one out on your own. All right, let's keep going, though. There are more things to do with literal equations. Take a look at this guy. We can actually use literal equations to solve problems. So in this problem, we have a half hour. So in a half hour, Sarah's going to meet her friends at the lake. Half hour. 6 miles from her house. We want to know the average speed she can ride on her bike to get there on time. Well, a formula that you guys need to know is that distance is equal to rate times time. So distance equals rate times time. So a way that we can write that in just letters is D equals RT. Well, it asks for the average speed. Average speed is a rate. So our average speed is considered a rate. Well, okay. So if our average speed is considered a rate, we're trying to get R by itself. So we highlight our R. Well, what's bothering R? Well, D equals RT. I'm going to rewrite it again. Our R is being bothered by the T. What's the T doing to the R? It's multiplying. So we're going to divide because that's how we get rid of it. But is it ever going to get any simpler than D over T? No. So our R is equal to our distance over our time. Well, guess what? We know what our distance is, and we know what our time is. What's our distance? Our distance is 6 miles. What's our time? Well, it says a half an hour. We usually do things in miles per hour, so we're going to write 0.5 hours. So now, if you type that in your calculator, you will get 12 miles per hour. So she got to ride her bike 12 miles per hour in order to get to the lake on time. So she must ride her bike 12 miles per hour to get to the lake on time. So not only can we use literal equations just to move things around, we can actually plug things in and solve problems with them. All right. The show you're learning is very similar, except for this time she's on the rush to get to the store and we need to know, can she get there? So I'm going to let you guys try that out on your own and see what you think. Let's look at example 3. Example 3 is a favorite of mine. It's a worker at a framing store is making a rectangular frame. He knows what the perimeter is. So he knows his perimeter is 144 inches. He knows his length is 40 inches, but he has to determine the width of the frame. So we got to use that handy dandy formula we started with. We know that the perimeter of a rectangle is P equals 2L plus 2W. We know our length, we know our perimeter, but we need to get W all alone. Well, what's bothering W? That 2L. So let's kick it out. Well, we kicked out our 2L. Now we're left with P minus 2L, because we can't do anything with that, right? is equal to 2w. W is still all by itself, so what are we going to do? Well, how is that 2 bothering the W? Well, it's multiplying. We know how to get rid of multiplication. How do we do it? We divide. So if we divide, we're going to divide by 2 on both sides. My computer was almost dying, guys. Sorry about that. So divide by 2. Divide by 2. The 2's cancel, leaving us with W equals P minus 2L all over 2. Sorry, there's our answer. P minus 2L all over 2. Well, now we can plug in what we know. How much is the perimeter? Well, it's 144 minus 2 times our length. What is our length? 40. And divide all of that by 2. If you plug all that in your calculator, you're going to get 32 inches. So the width of the frame is 32 inches. The width of our frame is 32 inches. Not too bad? Alrighty, awesome. We have one more thing to do and then we're done with this video. Yeah. The next one is about a triangle. You're going to do the same thing, but this time you're going to solve for the height and you're going to plug in things for a triangle. So try it out on your own and hopefully you understand it and we can work on it together next time. Or you can work on it with your teacher that's in there. Alright. Let's take a look at Tio and his bread recipe. According to Tio's recipe, he needs to bake bread at 190 degrees Celsius. Believe it or not, the other side of the world uses Celsius instead of Fahrenheit, unlike us here in the US. We use Fahrenheit. Our ovens in the US measure in Fahrenheit. How do we know what's going on? How can we figure it out? Well, they happen to have a handy-dandy formula just for transforming the two. So, our formula, as given here, is C equals 5 over 9 F minus 32. Well, what do I want to get alone? I need F alone. We need to know our Fahrenheit. So I highlighted her. So when I tell my kids, whenever they have a number next to a fraction, toss it to the top. So C equals 5 times F minus 32, all the way at the top, all over 9. We still highlight our F because it's still the one we're trying to get alone. Now, is it easier to see what we need to do first? We hate denominators. We hate denominators. How do we get rid of a denominator? We'll multiply by 9 on both sides. We got rid of that denominator, leaving us with 9C equals 5 times F minus 32. Well, that F is still not on his own. So we have two options here. My kids love to distribute, but sometimes we don't have to. Notice that the F minus 32 is just a number, right? Times the 5. If we were trying to get rid of this, we could just divide by 5, right? If we divide this entire thing by 5, it still cancels. So we divide by 5. Okay, that leaves us with 9C over 5 equals, sorry about my alarm, F minus 32. F is still being bothered. How do we fix that? Well, that's the easiest thing we've done so far. Sorry if you couldn't see it. Let me slow down. F minus 32 is what we're left with when we divide by 5 on both sides. Well, all we have to do to get rid of that is just add it, right? One thing I do want to point out is we are adding 32 to the entire side. So not just the 5, not just the 9. So this is 9C over 5 plus 32 equals F. Now we can figure out how many degrees Fahrenheit we need, because we know our C is 190. So F equals 9 times 190 divided by 5 plus 32, which is equal to 374 degrees Fahrenheit. So we gotta set that oven to 374 degrees Fahrenheit. So set your oven to 374 degrees Fahrenheit. The very next problem just has you use Celsius. The only thing I'd like to point out about this problem is sometimes when you're looking at literal equations, you're going to think, oh God, I got to solve for something. But notice, the high temperature was given in 5 degrees Fahrenheit. You already have a formula for Fahrenheit and Celsius. You know the formula is C equals 5 over 9 F minus 32. So all you have to do to find Celsius is just plug 5 into F. Sometimes it will be that simple. So try that out. See what you get. All right, guys, we're almost done. I'm staying below 30. I promised. I'm doing it. So this is just a quick review. So if we have A equals BH and we want to solve for B, then B is our one we want on its own. So I'm going to highlight our B all the way through. Well, notice H was bothering it, so we divided each side by H. Okay? Not too bad. Now look, it's doing the same thing we did, guys. It's got P equals 2L plus 2W for L. We want to solve for L. We want it all on its own. So I'm going to go ahead and highlight L all until it's by itself. Well, first thing they did was subtract 2W. So, subtract 2W. Then what they do? They divided each side by 2. Not too bad. So now, what I want you to do is take a quick gander at this equation. We have ky plus 3x equals 8. They want to solve for y. What did they do wrong? Well, I don't see anything wrong with subtracting 3x. That's fine. Then they divided by k. That's fine. But look what they did after that. 3x over k does not simplify. This guy right here. We don't know what k is, so there's no way we could just drop that to a 3x. So our actual answer should be y equals 8 minus 3x over k. He should have just left it like it was. He was done at that point. All right. And last but certainly never least, take a look at number 3. He didn't want you to tell it what to do. So we're solving for x in both situations. So here we are solving for x. Well, we hate denominators, so what are we going to do? Kick out that denominator, right? So we're going to do 6 times xy over 6 to kick out the denominator. But what we do to one side, we have to do to the other. So we multiply by 6 there. Well, what's going to happen? It's going to turn into exactly what it has next. xy equals 6w. Well, that x is still not by itself. What's bothering it? The y. So we're going to divide by y on both sides, and that's going to cancel out. So what's our final answer? 6w all over y. All right. I want you guys to try out B all on your own, and good luck. I stayed below 30 minutes. Have a great day, guys. If you ever need any help, please feel free to come and ask me for help. Goodbye.